Hello all, welcome to Tech with SAS. In this video, we will talk about caching. Caching is an important aspect if you are trying to master system design. So let's understand why caching is helpful or it is being used in our applications. So now here we have an application, maybe it is like some e-commerce application where user is trying to get his details of order, right? So for every order ID, whatever we receive from the user, application is going to check in database and send back to the user. But if user is like trying to get details multiple times. So every time application has to go to DB and fetch it. So it becomes like an extra hop for the application or the system, and sometimes it also increases load on the database. So the solution for that is we can use the cache. So cache is basically a kind of like a limited memory but very fast accessed. So what happens that for the frequently asked or access values, we can store them into the cache, and next time when user want same data back, right? So application will first check in the cache. If it is available, it will send back. So it will call the cache hit. But suppose that user is asking some value first time. So in that case, there will be cache miss, and then app will have to go to database and get the value, and then first it will basically update the cache with that value and then send back to the user. So next time when user want same value to be fetched, the app can serve it from the cache. So it becomes a really faster to access data, and also it's a good experience for the client because the extra trips which application was making to DB and maybe some complex computations which it was doing, they avoided. So cache is really helpful in terms of basically having a good performance for your application. So there are a few benefits like when you use the cache, right, there will be less number of network calls because for any order ID or any request, you will just fetch it once from DB and store in the cache. Next time, you can serve it from the cache itself, so it avoids the network calls. Second thing is that suppose for any calculation you are doing, so for every request, either you can do multiple type calculations. So you can once you do the calculations, you can save in the cache itself, right? So next time you can avoid those calculations and you can serve your customers really fast. And yeah, and third thing is that when you use the cache, you can avoid the multiple calls to DB, which help us to reduce load on the DB as well. So that's like, so these are the various points by which we can say caching is really helpful in our application system design. Now, once we have data cached, right? So data will not be cached forever. So you have to make some strategies to refresh it because suppose you got some data maybe 2 hours or 3 hours back, maybe it got changed, right? So we also have to make sure that our cache is up to date and we are evicting the values at right time so that whenever we are serving to customer, we are serving them the fresh data, not the stale data. So there are some cache eviction strategies which are really important so that our cache is always always remains up to date and we are serving the correct data to the customer. So first thing is that the cache invalidation. So in that, like you have to like define some like parameter like TTL, like time to live. So suppose here we can see that there is a cache table where we have stored like a key value and detail columns, and we have user one, user two. So you can see that like you define, okay, for the user one, time of live is 5 minutes, and for two is 10 minutes. So after 5 minute, right, this will go out. So what happens that so next time, suppose after 6 minutes, when user one want the same value again, so at that time there'll be cache miss because the previous value which was stored into the cash was evicted because it was like a like it was expired value. So this is the one strategy, like by using the time to live, we can define. So now the how to define the value, so that depends upon the use case. So whatever the use case we have, we have to fine tune based on that. So maybe for some data it might be in hours, because you don't expect it to change like in seconds, but for some data, it might be critical to refresh it in maybe 5 seconds. So every, I mean, we can't define any particular value as such. For every use case, you have to holistically and think and decide the TTL value for the your cache invalidation. Next strategy is the cache eviction strategy is the FIFO, like the first in, first out. So in this, what happens that we can see, okay, whatever data which it came first will go out first, right? So maybe like even if your cache is suppose not full, right? Even then it's fine. But suppose your cache get full and you want to add one more value at that time, you can use the strategy of FIFO. So what happens that whatever the cache value which you cached first will be flushed out or evicted. Then you can insert the fresh value. So, for example, here we have the user three want to like we want to put it into cache, and for example, our cache got full, right? So we will see, okay, the so user one has the like treated as 15 minutes, right? So it came earlier than the user two, so it will evict user one from here because it was placed first in the cache, and then we will insert the fresh value, I mean user three value into the cache. So in this strategy, we check what is the first in first out data that is going to be evicted, and then you can insert your new data into the cache. I mean, the most popular strategy is the LRU, or least recently used. So in this, what happens that we check that, okay, which value was recently used. So it means that if something was recently used, it's like more hot, or maybe it's like user is really active. So whatever the least recently used, we will keep it. But what was accessed a long time back, we will remove it or evict it from the cache. For example, here user 1 value was accessed 2 hours back, but user 2 was accessed 2 minutes ago. So it means that user 2 is like more, I mean, accessed I mean, recently only. So the LRU value is user 1. So when you want to refresh the cache with the, I mean, you want to put the next value into the cache, then you have to remove the user 1 and then add the user 3, whatever data we have got now. So in this strategy, we check, okay, what is the least recently used value in the cache. Then whatever was accessed long back, we remove it from the cache and put the next data into the cache. So these are the cache eviction strategies by which we can keep our data in the cache as a fresh, not stale, so that we want to make sure that our customer always get the real time data, not the stale data. Maybe something has changed in the database, but you are not updating your cache, so it gives a bad experience for the customer. Then another cache eviction strategy is the LFU. So we will check, okay, what are the frequencies, like how many times it was accessed. For example, you can see here, right? User one was accessed 10 times and user 2 was accessed 25 times. It means that user 2 is more active or like a most frequently used. So the least frequently used value is user 1. So that's why we'll remove the user 1 from the cache and we'll put the user 3 into the its place. So this is also a good strategy. Like you can keep the count how many times user is accessing that value from cache. So whatever the most frequently used value you should keep in the cache, but whatever the value is least frequently used, you can remove it from the cache. So yeah, so these were the various cash evasion strategies. So by that, we can make sure our cash remains fresh, and we are serving the real-time data to our customers. Now we will see. Okay, so now we I think we understood what is the importance of cash and how to keep it fresh. But now suppose as a designer you want to think, how do I where do I keep my cash? Like we have, suppose we have four actors here, like user, application, database. Where do I keep our cash so that we get the good performance? So for example, one strategy is the cache aside pattern. So in this, what happens that application talks to the cache, and then we it serve also the customers. For example, user one is requesting some value from the application, then app will first check in the cache. If data is found in the cache, it will serve back to the customer, and it called as a cache hit. So whatever data user want it to access, it was available into the cache, so that's why it's a cache hit. But suppose what happens that user want to access data, but it's not available in the cache. Okay, so at that time we call it cache miss, and then app will go to DB and get data from over there, refresh the cache, and send back to the user. So in this, what is happening that cache is not talking to the database; it just talk to the application. So application is responsible to read from the cache and write or refresh the cache, right? DB is not involved here. So the cache is kept aside of the system, right? So whatever the access is happening, it is happening by application only. So application is going to refresh the cache, update the cache, and read the cache, right? So whenever you have the read heavy, right? Suppose there are some like news feed example where you have you know that there's a read heavy. So at that time, data you can put in the cache, and whenever there's a request from a user, you can read from there. And also, suppose your cache is gone down because of some reason, right? Maybe it's network failure. At that time, whenever there is a cache miss, it's going to serve from the database. Even, I mean, yeah, so it will add some latency because there's extra network call, but still you are able to basically serve your customers. Then you also need to keep DB and cache in sync because they don't talk to each other. So you have to make sure that you set the appropriate time to live or whatever app code logic you want to define, right? Define into your application. So that is really important when you are using the cache side pattern, and then cache is able to refresh itself using this TTL or app code logic. Next strategy to put cache is the read through cache pattern. In that, what happens that we put the cache between the application and the database. So whenever there's a request from the user, the application is going to check from the cache first. Data is available into the cache, then it will serve. Otherwise, now cache is responsible to fetch data from database and update the cache and send back to the user. So here the app is not going to talk to the database directly, but whatever interactions which are happening to database, they're happening via cache itself. So that's why we call it read through cache pattern. So whatever, whenever application is hitting cache and is able to get value, we call it cache hit. We can serve from the cache, but whenever it's a cache miss, we will load. I mean, cache will load from database and serve it to the customers, right? So in this, the main idea here is that the application and database don't talk to each other. The cache is the mediator, and that is going to talk to both of the components. Then, yeah, it is also very good whenever you have a read-heavy systems like newsfeed, like so okay, like whatever data you want to serve, right? You can load into the cache. But only issue is that whatever the first hit is going to come, right? It's going to be a cache miss because if so, solution for that is you can preheat the cache. Maybe like data, okay, the hot data which is need to be served to customers whenever app is up, you can load it before the app is going to start serving customers, so that there will be less cache miss. Otherwise, if you don't load the cache like previously, then you will be getting the cache miss initially, and for every cache miss you have to load it from the database. So best way is to preheat the cache and upload data which is like you think okay it's going to be asked from the customers. And then even suppose your DB goes down for some time, right? So even then you can sustain for some time because cache is there to serve the application or the customers, because DB is anyways going to talk to the cache only. So whatever data cache has is always up to date, right? But yes, whatever any read are happening in case of cache miss, or in case of yeah, cache miss. So at that time there'll be extra hop, like because cache is going to talk to the database. So yeah, it will add some latency for this pattern. Next pattern is like same pattern like the previous one, but is in this like we have the write through cache pattern. So whatever the I mean whatever the data is coming from application will write to cache first, then cache is going to write to the database. So I mean the main thing is that all the writes are happening via cache only. I mean what the previous one, but here it's going to be like adding a latency for this. So in this like same thing happening, right? We can whatever we can the preheat the cache, and so that we are able to serve the customers. Otherwise, they're going to be a cache miss for the initial calls. Now, this one is basically the write back cache pattern. In this, writes are happening to cache, but cache is not going to write the database at same time. It's going to batch those data and asynchronously update the database. So, at some point of time, cache is not in sync with the database, but cache has the values which are like most up to date. So, whenever any write is request coming from the application, cache is going to store in that, but it will wait to accumulate the bulk of the request, then it will upload that data into the database using asynchronous mode, right? So this is the basically difference. Like it in this there is no synchronous write to the database, but it is kind of asynchronous write to the database. So whenever you have like a write heavy system, so uh, for like multiple requests are coming for write, so you are holding right, so that what is happening that you hold the writes in the cache, then but when you have the enough write request, then you load into the database asynchronously, so that becomes more efficient and you can save the time as well. And also, in case DB goes down, right, at that time, what happens that because your cache has the data which is up to date, so you can serve your customers for some time. So until unless cache gets full, so you are able to sustain the DB failures as well. But in case what happens that suppose cache is goes down, right, because cache is a critical component here, because cache has all the data which was sent by the application, and if it is not read written to the database, so if cache goes down, it's a disaster for application. So yeah, these are the various pros and cons for this pattern. Then we also have this right around cache pattern. In this, like if you remember in the previous pattern, right, all the writes were going to the cache. So, but here what is happening that the writes are going directly to the database. Like suppose any application want to write some data, it will not come via cache. It will come directly to the database. So app will update database directly. But for any read request, it will come to the cache. So now for any cache reads, app will call the cache system, and if data is there, it's basically a cache hit, and if it's not there, it will load from the database. But for any writes, it will directly write in the database. So this kind of like a dependency is not much on cache, and app and database can talk to directly. This is called basically called as a right around a cache pattern. So yeah, thank you very much for the watching. I think it was hopeful. So I tried to cover the various cache evolution strategies and cache strategies, like where do we place them. So yeah, thank you very much for watching. See you next time. Please leave comments or questions. Please subscribe to my channel as well. Thanks a lot.